Example 4 says estimating sales per share. So the sales per share of Amazon.com was 105.65, so $105.65 in 2011, and $134.40 in 2012. Using this information, write a linear equation that gives the sales per share of the item in terms of the year. Estimate the sales per share in 2013. So here's the first thing we need to do, is we need to give this a variable. We need to give it, so we could use y equals mx plus b. That's perfectly fine. I really, truly don't care what variable letters you use on this one, but you need to tell me what it stands for. So for instance, you might say y equals the price per share. And the price per share depends on x, which is the dollars per share, or the year. Okay, so that's totally, those are the two things that we're relating here. We're relating the price and the year. And so you have to think, which one do I make X and which one do I make Y? Well, let's think about this. Y is usually, almost always, dependent on X. So Y is called the dependent variable, X is called the independent variable. So X is what you plug in, Y is what you get out. That's what you guys know most functions to be. That's not always true, but that's how we generally do it. So here we have two things. You have to think, does the price depend on the year, or does the year depend on the price? And in this case, we are inferring that you tell me the year and I can tell you the price. In other words, the year is the input, the price is the output. So that's why I said Y is the price per share and X is the year. But now we need to be a little careful here, because X is the year. Do I really want to plug in 2011 and 2012 and 2013? Or do I just want to plug in something else? So one of the tricks you're going to see is changing the year to be like the year or number of years. Let me change this up. Let me erase this. How about we make it the number of years since 2000? So instead of plugging in 2011, I'd actually just plug in the number 11. And instead of plugging in 2012, I'd actually plug in the number 12. So why would we do this? Well, that just changed our X values dramatically. Our X values now are much, much, much smaller. Instead of 2011, I only have to plug in 11. So I'm dealing with smaller numbers here, makes it a lot nicer. So that's one of the tricks you're going to see in numerous problems throughout the semester is, if we're talking about the number of years, it's not going to be directly the year value. It'll be the number of years since some point in time. For instance, since the point 2000. Okay, so let's think about this then. Let's think about our ordered pairs. What ordered pairs does this give us? Remember, the year is the X value, and the dollar amount is the Y value. So this first one, the X value is 2011, and the Y value is the dollar amount, which is 105.65, because the price depends on the year. Let's look at that second one. Think about what point we have in this one. The year was 2012, and I'm already doing something wrong. Let me finish what I was doing, though. And the price was $134.40. So again, this would be if we use the X value to be the exact year. But my mistake is we just talked about, just a brief second ago, that X is the number of years since 2000. So 2011 and 2012 actually wouldn't be the proper answer here. I need to come back in here and change it. Instead of 2011, we're going to put an 11 there because it's 11 years past the year 2000. Instead of 2012, I'm going to put a 12 there because it's the number of years since 2000. Okay, so those are my ordered pairs. Those are my points. So the first thing that I need to do on this is find the slope. So let's find the slope of the line. If you remember to find the slope, that's y2 minus y1 over x2 minus x1. So let's look at this. Look at those points that we have. So the second y value, the second price, was 134.40, minus the first y value was 105.65. The second x value was 12, and the first x value was 11. Just again, remember, you got to make sure that they line up. For instance, here's the point 12, 134. They should be straight on top of one another, and they are. So again, I'm going to have you use your calculator. Your calculator is vital that you get used to this. Let's see what you get as a slope. Plug it into your calculator. I'm getting 2875. Now, just to give you an idea, I don't care about units because that's not the point of this problem yet. But think about what the y value is. The y value here is dollars. The x value here is years. So what does this mean? This means that it was increasing. The price of the stock was increasing by $28.75 per year. Through those two dates, of course. We can't necessarily say this is what's going to always happen, but through those two dates, that is most definitely what happened because those are the points we use. Okay, so now we have the slope. We need to move on to the second point. So what's the second part? The second part is find the equation of the line. I'm just going to write find the line, and we're going to use the y2 minus y1. We're going to use the y minus y1 equals m times x minus x1 point slope formula, because now we have both a point and a slope. Again, this value right here, this 2875, that is our slope, and then we actually have 2 points, and it truly doesn't matter which of those 2 points you use. It's totally up to you. It'll work if you use either of the points. So I'm going to do the math for that now. I'm going to do y. I'm going to choose, how about I choose the first point, the 11, 105, 65. So when I plug this in, I end up with y minus the y value, which is 105.65, equals m, the slope that we just found, which was 28.75, times x minus the x value, which was 11 for the point. Okay, so now I just need to do some algebra and clean this up, make this look, put this into slope-intercept form. So I'm going to start by distributing the 28.75 to both of these. So I end up with y minus 105.65 equals, well, 28.75 times x is 28.75x, minus, and then I have to do 28.75 times 11. Please check my math on this in your calculator. I'm getting minus 316.25. Again, I want to isolate the y here, so I'm going to add that 105.65 to both sides. When I do that, I end up with the equation y equals 28.75x, and then I'm getting minus 210.60. So that would be my linear equation here. Again, it's very, very important for the reader that we've identified and provided a key to say what each one of those variables stand for. So here, y was the price per share in dollars, I guess I should write there. Sorry, let me write in dollars. And then x was the number of years since 2000. So my linear equation becomes y equals 28.75x minus 210.60. Okay, so again, really, really important here. Make sure you've provided that key so we understand that. You didn't have to use the variable x. I've seen a lot of people use like t or for the year, for time. Totally up to you. I like using y and x whenever possible. Now let's look at the second part of this problem. The second part of the problem wants the 2013 estimation. And remember, 2013, since that's the year, what we want to use is the number of years since 2000. So 2013 is 13 years after the year 2000. So what we're going to be doing is plugging in 13. So step 3 for this problem is evaluate at x equals 13 for the year 2013. So all we're going to do is plug it into that equation. So we have the 28.75, but instead of x, that's where I'm going to plug in the value 13. I come back over here and I have the minus 210.60. Plug that into your calculator and let's see what you're getting. I'm getting a total of 163.15. 163.15. And again, y here is the price, the cost of the dollars in shares. So if this trend continues, if they change at the same rate of change from 2012 to 2013, which is not guaranteed, we don't know, but we're going to use the model from 2011 and 2012 to predict what will happen in 2013. So our prediction, our estimate is that the cost per share, if it continues at what it's at, would be $163.15 per share. So that's what it is right there. That's using an estimation, okay? So let's do a little summary for lines. Again, vertical lines are always x equals because the x value never changes. Horizontal lines are always y equals because the y value never changes. You've got to know your point slope form, which is the y minus y1 equals m times x minus x1. That's when you are given a point in the slope, when it's any point on the line. Anytime we have a final answer, we want to put it in slope-intercept form, which is the y equals mx plus b. There's also an equation called general form, which is when you set everything equal to 0 for a line. We will very, very rarely use general form in this class, but that is another form of the lines. I wouldn't worry about that too much. What you're primarily concerned about is the point slope form and the slope-intercept form.